The broadcast is now starting. All attendees are in listen-only mode.
Sound check, testing sound. If you can hear me, can you click on the hand icon? Great, thank you. There are some names in here of people I recognize. Some have seen more recently than others. So nice to see your names there. I'm now going to start sharing my screen. So please let me know. Welcome to the first lesson of a series of lessons that are given in webinars. We have 11 of them, and we will be doing them every Thursday, both in the morning and afternoon Pacific time, so that anyone in the world would be able to listen in. But it's all about modeling or doing water management modeling in GoldSim. And so we're going to start off with some how to do some hydrologic simulations, then talk more about components of a water system and how to simulate those components, followed by some more advanced settings. So over these next 11 weeks, actually 12 weeks because we have a guest speaker in October, then if you can follow through with all of these webinars, then you should have a pretty good understanding of of the kind of things you want to look for and use in GoldSim when you're doing water management models. Okay, so this first one, we will be talking about simulating, or I should say incorporating precipitation into your models. And I say it that way because it might just be a matter of accessing data that you might find and doing stuff with it, being able to incorporate it in your simulation. But at other times, you might actually simulate rainfall. And one of the ways to do it in GoldSim is using the Markov Chain method. And so we'll talk about that toward the end of this presentation and start with the most simple, the most basic way to represent rain. This way would be just using a static constant, where you might call this, annual average or annual total precipitation. Either one would be fine. Why don't we just say annual total precip? And we'll put it in units of millimeters. And then I don't really know a good number in millimeters because I don't work that much with it. Okay, maybe 2,000 is a good number for millimeters. Oh, wait a second, what was I thinking? 40 inches a year is here. Okay, so about 1,000 maybe is a good number for annual precip. Okay, all right. So now what we can do with this is, well, not very much besides just show that that's the annual amount. But let's say we're doing a simulation of, let's say, 2 years into the future. So we can set up a model that's calendar time. And then let's just say we go for a regular calendar year time frame. And then I will do a future run. So this is 2021, 2023, one-day time step. Okay, so if we're doing a multi-year run, this really won't help us much. But sometimes if precip is not a major influence on your model, then annual averages maybe for a big picture type model, but it's probably pretty rare. So what you might actually do instead is perhaps apply a seasonal factor to your total. So that's one way to do it, and we could do that with a lookup table. So we could say seasonal factor, where we might use months as a way to look up a value that would return some factor that you multiply by the annual total to get it to distribute through the year. So what we could do here is then edit a table, and I already have some data here, so I'm just going to move it over. Okay, so in this table we have, first of all, it's supposed to represent the months January through December. But if you are looking at a decimal month where, for example, as you get closer to the end of the year, December 31st, let's say, you start to, it's a decimal value added to 12, so about 0.9, so about 12.9. January 15th might be 1.5, about halfway through the month. So if you were using decimal values of month, then you'd want 13 rows. But I'll show you how we would use that here in a bit. Let's just assume we have 12 months, 12 values, and these are just relative factors. All they are just relative to each other. But we could put in a value that if you add them up or you sum them, they add to 1. We could do it either way. If you don't add them up, if they don't add up to 1, then what you'd want to do to create a normalized factor would be to divide each of the values by the average. And so a good way to do that is actually using a vector constructor. We can build an array on the fly using the vector constructor. So those of you that might be new to that, the syntax is vector, and you can also look these functions up, by the way. So you just right-click in here and go to functions, and then it would be under array operators. So vector constructor, there it is right there. So it requires the first argument to be the name of the array label set. In our case, we want months. And that's just a built-in default array label set that just happens to exist in GoldSim already. I didn't have to create it. And then the following one is the value. And in our case, what I want to do is I want to do a lookup on our seasonal factor table because it has 12 values in there. And I want to build a vector of those 12 values. So then I can just refer to the seasonal factor. And then this is the tricky part, this next part. I'm just going, right now I'm building an array of months, and it already has indexes in it of 1 through 12. Each of the rows of that represent each month each have an incremental value 1 through 12. And so knowing that, when I use the vector command to build a vector, I can refer to a variable called row, which in this case counts 1 through 12. So essentially we're doing a for loop over 12 rows and grabbing the next seasonal factor for the next incremental month. And the result of this is a vector. So that's why it's giving us this error, but I need to go one step further, and I need to divide the seasonal factor for each month. And now I'm just grabbing the one value out, and then I'm going to divide it by the mean of all of those values. So what that will do is, as it walks through time, it will provide you with a normalized factor. So if we called this seasonal factor, then I already have that value. That should be the table. So I'm just going to put an underscore, change this to table. Lookup tables probably should always say table at the end. I feel like that makes it a little bit easier overall. Okay, so now we have this factor, and then we can multiply that by the annual total to give us the monthly depths of rain. So we do annual total and then multiply it by seasonal factor. And then those are monthly totals. So in order to get the rate of change over time, then we should divide this by the number of days in the month. So I'm going to put parentheses around this. And we will say days in month. That's just a run property that's available. If you ever want to see what GoldSim has available already in it, you can start by typing the tilde symbol like this, and then start typing the variable that you are looking for, in our case, days in month. And okay, that's the number of days in the month. But I need this to be a rate. and then we want to multiply this days in the month by 1 day. Okay, so that's 1 day. See, the variable days in month is a unitless variable. It just counts 1 through 12. I'm sorry, it doesn't count with it. It counts either 28, 29, 30, or 31 days, depending on the month that we are in. Okay, so that would get us a precipitation rate over time. That looks like this. Okay, so with that, then what we can do is that will give us a factor that changes. But another way that's very common is to just see a vector. So in this case, we might have, instead of a scalar value, we might have a vector. So to change an input to a vector, you simply change its type here like this, and then we can say monthly totals. Monthly totals. And so then in here, let's see, I think I've already saved them. Here we go. Okay, so once you paste values in, you can't have the units on there when you paste them in. Well, they don't make sense in Excel to have units tied to them. So I have the units off to the side, but when you paste them into a table like this, you'll see that if you hover over the value, that it just assumes that you intend this to be the display unit. Oops. So, and because of that, well, because of what you put in the display units here, it's going to assume that those values are also that unit. So when you reopen it, you'll see the values or the units are appended there. Okay, so obviously then the way that you would reference precipitation would be similar, but you would just take that for each month. Now there is one other type of model you can use that will, instead of it, in this case, when we look at the precip over time, let me just do the equation real quick here. So if we said millimeters per day, and then we reference these monthly totals, if we do that by month, and by the way, we have to now divide those. Well, let's see, these are millimeters per day. Oh, okay. So those are already millimeters per day. I'm sorry. We should change these to millimeters per day. So this is the average daily. Okay. So let's see. We do have a question. Somebody asked, is it possible to introduce daily values of evaporation? And that's a really good question. We will cover that next Thursday, actually. That will be covered in the next one. We'll be talking about temperature and solar radiation and then how you can calculate evaporation. So that will be next week, yes. Okay, so here are our precip values, these monthly values like this. And I had to change them to a rate because I'm using a monthly average rate. And then all we do to access those values on a monthly basis is refer again to this run property month. And when you plot that, so if we were to run the model and plot this, then you would see that these are squared off values like that. So what we want to do instead is possibly do some interpolation, because that chart that we were just looking at, it's well, let me show you. I should probably change that to rainfall. I'm being a little bit lazy with the name that I'm using. Okay, but let's go ahead and run this again. Okay, so when we look at this plot, you can see that it's fine in that it tells us average monthly. But the problem is we have a 1 day time step, and so what happens is your model might be running along fine and then all of a sudden hit this very big jump. That's not as big as some other jumps, but you have some fairly large and fast jumps that happen within 1 day. And this sometimes causes havoc downstream in the model. And it's not a real thing, right? It's an artifact of the way the data is represented actually. And I've noticed that in some models that these jumps like this cause problems that people didn't realize. Maybe if they're calculating whatever it might be, infiltration or runoff or something to the model. So what's a good way to get around this is to just do a simple linear interpolation. The one downside to this is that you can't get a very accurate or precise equivalent monthly total if you do just a very simple linear interpolation of these values. And so what I mean by that actually is that instead of referring to where do we refer to the month? Right here on our seasonal factor, instead of referring to the month, we would refer to a decimal month. So let me just give one example. We could do it with either of a lookup table or a data element, but a lookup table is a little bit easier because you can put 13 rows in here. So let's just say, for example, that this is our monthly total, or no, sorry, I should stop saying total because we're using averages. Monthly average precip table. And so we have the months here. We go to edit the data, and there are the values, although it results in millimeters per day. So millimeters per day. So those are the values over time. And so with this table, we could, instead of having the constant over all the days in the month, instead what we can do is if we refer to this new table, it's going to result in millimeters per day again. And then we say monthly average precip table. Now, instead of referring just to the month, that just is a constant value over the days of the month. Instead, what we can do is we can add a decimal portion to this. So instead, we could say the day of the month. This is another built-in property. You can also find it, oh, sorry, I think it's called day of month, but you can find it by doing this tilde thing again. Day of, there it is, day of month. Okay, I just hit the tab key to complete that. Then I'm just going to subtract 1 because we want the very first day of the month to be 0 in our case. Okay, so with that, then we divide it by the days in the month. Okay, so I think what that would do is give us a decimal day that would then look up a value that interpolates those values linearly. So we could then add the second expression output. We'll call this linear interpolate rainfall, and let's see what it does. Okay, so here it is. So you can see the problem here is that everything is shifted. Not only is it shifted, but there will be some months where you underestimate if you were to integrate these rates over time. For example, this month, July. Well, now I'm wondering why the rainfall is the highest in July. But anyway, this month of July, you would probably undercut the estimate because your peak of this triangle just hits the top there. Anyway, it would cut off probably too much. And then there'd be some other months like this month where it might be too high if you took the average, you know, of those, because it's shifted. Okay, so you can do some tricks with this. You could add 15 days to the values so that they get shifted to the right. That's definitely possible, but you still don't end up with a very good estimate that approaches these values. So we have interpolation functions in our library that you can then just copy and paste into here. So let me show you one of those. And I'm just trying to see if I have one already on my list. I don't. Okay. Oh, there it is. Okay, so this is a model you can get from our library on our help center. And all this does is it allows you to define just a simple monthly set of values for your rainfall rates. Okay, and that's all you need to fill in. And then when you do it, it can provide to you a spline interpolation. Now I realize now these are monthly averages, so this is not true to what a daily precip realization might be, a time series, right? You'd have individual events and so forth. But if you're just calculating on the average what precip is, you know, for say, for example, a water balance model, then this might be useful. And this spline interpolation provides a really good close fit on an integral through time. And so it's a pretty good approach, and you can see it repeats for as many years as you want. So you could make this simulation run for as long as you need, and it just repeats those 12 values you put in the table. So this could be easily something you just copy and paste into the model we're working on. Okay, so that being said, let's move on to a totally different style of model. Let's see, I just want to make sure. Okay, I don't need to save that. Just go new. Okay, so this next model, and don't worry, I do have copies of these models that I'm working with here, so I didn't just lose all my work. All right, so this model, what we want to do is look at time series. Okay, so the time series is found in the inputs category, and then we just go ahead and click on time series, add it. We could call this something like precip time series. And again, the display unit's very important. Well, I always skip over descriptions for time, but you shouldn't. But anyway, the display units, this is really important actually with this kind of a value of rainfall, because you might confuse a rate with a discrete amount. It's not something that you have to worry about too much with Excel, because with Excel, it might just turn out that each row represents a day, and each value is a rate that's per day, and so it's the same, either the amount or the rate is the same, and so you don't even care about that that conversion. But in GoldSim, you have to really be aware of what your units are. And so with rain, because we are on a one-day time step, it would fit nicely just to give it a rate of millimeters per day. That works if you have a daily time step. I mean, it works the same, but it's more straightforward if you have a one-day time step as well. But let me just go ahead and change this to, again, a future simulation. Whoops, 2023, I think is what I wanted. And then this one, 20, okay, so this will go for 730 days. Okay, so, and I probably shouldn't have done that because I actually want to do a historic run. Okay, what I did before this presentation is go and get some data. So one good place to get it, and this webinar is not really about this subject, but I just wanted to just let you know that this is a really good source for data, especially precip temperature data. So it's the NOAA National Center for Environmental Information, and I'm just going to copy and paste this link into the chat in case you wanted to see it. Okay, so that's something I've been using. Somebody asked if I could repeat how I got the interpolation. If you don't mind, I'll wrap back around to that at the end, if you don't mind, just for sake of time. But I will let you know about that. I'll show you again. Thank you for asking. Okay, so anyway, so you go in here to browse data sets, and then you can pick the type that you want, and then you essentially order it after you click order, and it doesn't cost anything. You order it, and then, well, at least, I mean, for the sets I was getting, it didn't cost anything. But anyway, they send you an email when it's ready, and you click the link and get the data. So that's what I did, and now I have this information in here, and this is precipitation for Salt Lake City, Utah, and it's from the dates, years 1948 through 2018 is what I happen to have in here. And so an easy way to get this information into GoldSim, let's say for example that all I want is rain in millimeters. Well, I've got that column all the way over here, and I've got the dates all the way over here. So what I usually do is I just Control Shift down, copy just the dates. Then I come in here in GoldSim. I set my model up to be date time. Then I create a new time series with the correct units. Then I come here to edit data, and well, because I created this element before I changed to calendar, it says day, but just watch out for this value here. It should say calendar if you're pasting calendar dates, which I am. And by the way, if you're in a country that uses the swapped month day, well, actually that's the correct order. We are the ones that are swapped over here. But if you're using the swapped values, just know that your system will take care of that. It'll copy and paste just fine on your system. Okay, so then we come back over here to Excel and we go to rain, and then I'm just going to Control Shift up, just grab that data, copy, come back over here and paste. Now, what GoldSim will do when you click OK right now is it will try to validate what you just pasted. And if it finds anything that's not a number, a value in the right column and not a date in the left column, then it's not going to allow this to be written into memory here at this time. It'll be lost after you click out of that. Well, it won't be lost, but it won't let you leave this page that we're looking at until you fix it. And so the reason for that, we don't want, let's say there's a blank, let's say for whatever reason, the data that comes in, there's a blank value. We don't want to assume what it is. And we could argue about things. We could say, well, by default, make it 0, but we just don't want to do it. We don't know what's coming in, so we require that you fix it first before you bring it in. Now, you could just fix it easily with a code, -999 or something, and then GoldSim could have logic in it that figures out what to do with a -999. Easy workaround. Okay, so that is the precip. Now that we have that data in there, we should actually just run a historic run so we can just kind of visualize what the data looks like. It's always a good idea, just to make sure there's nothing weird about it. So it's going from 1948, just hitting the down arrow, okay, to 20. I'm pretty sure that's the date range we want, and then it's daily. Okay, so now we run it, and we get, if I do these plots keep ending up on my other screen. Okay, so it looks reasonable, and we can zoom in by holding the Control key and just drawing a little rectangle, and that allows us to zoom in to see individual rain events in the data set. Okay, so that makes sense. What a lot of people might do in GoldSim, in the actual applications like this, would be to do a time shifting, actually. And what I mean by that is they would run a Monte Carlo simulation, and then they would randomly sample in this series to represent some future situation. And it might be multiple situations. Well, they call them realizations, actually, in Monte Carlo simulation. So we would have multi-realizations that would run one after the other. And each time we would run a new realization, GoldSim randomly picks in this time series and spits out a new one that's copied from some historic random point in time. However, you can make sure that your start time is aligned, which is important. You want January values when you're in the month of January, for example. So that means each realization it runs, it has to go pick a random starting point that aligns with our simulation, and that's what it does. Okay, so let's just see how that works. Let's say we want to simulate some future scenario. Let's say start in 2021, and we'll just go 1 year, 2022, and then let's run. Now we could just say 100 realizations, but what GoldSim's doing is it's sampling what we have. We have about 70 years on record here. So if we go over 70 realizations, then it's just going to start repeating years that it's already picked. So it's fine if you want to do it that way. I don't see a problem with it, but maybe you don't want that. Maybe you want it to only sample just the years that you have, and so you would put that number in. I'm know if I've got the right number, but anyway, so you put that in, and then it gives you a warning that says, hey, you're not going to see any results. You're not going to see any results unless you put a time history result in here. This is the only way to see time history results in a Monte Carlo simulation, is if you add the actual result here. So I'm going to add a permanent chart, and I'll call it precip history, just so we have something. Okay, and then there's the value. Now when we do a run, it's going to tell us something. It's going to say, whoa, I don't have any data for year 2021. That's a future value. I'm a historic time series. So then what we need to do is what's called time shifting. So we go into the time series here and click on more, and then there's this box, enable time shifting of the data. And by default, it picks an option that you would probably never use, and that is totally random points that have nothing to do with time, the calendar at all. And okay, and that might be applicable in some cases, but for hydrology, I can't think of a time when you'd want that. There might be some, but anyway, we want annual. So what that means is it'll pick some annual starting point, aligned with our simulation, of course, but it always goes and picks a random annual starting point on each realization. If you run a simulation longer than 1 year in this set, it doesn't go resample again on the end of the year. It'll continue for the whole simulation, for the whole duration of that realization, however many years it is. It'll just keep walking through the time series. So now your next question might be, well, what happens if you hit the end? So let's just say, for example, that in GoldSim, it picks a random starting point of January 1, 2017, the very end, and we run it for 2 years. So what the simulation does, what GoldSim does, is it gets down here to the bottom, and when it hits this, we still have another year of simulation left. It'll just wrap all the way back over to the start of this time history, the first year, and continue. That's what it will do during one realization. But at the beginning of each subsequent realization, it will pick a new random annual starting point. Okay, so it's really easy to set up, and once you do that, then it makes it really easy to just go ahead and just run the model, no errors, nothing, no problem, and it will show you a probabilistic time history of the rainfall. And you can look at this in different ways. Here's a single realization. We don't know where this is in time. It's a random year. We don't know which random year, but the point is the months, well, the time is aligned with our simulation calendar. We can also look at a statistic. So here's the mean rainfall, the mean of all the values that occurred, many of which were 0, gives us this mean of time values. Okay, so this is nice, but there's something that's also very easy to do and also very powerful, and that is reporting. So we have a daily time step model, but what if we want to show monthly and annual values, let's say totals, in addition to our daily? Well, we can easily do that in here in the settings by just changing the reporting steps from none to major minor periods. And I picked 2. You can pick just 1 if you want, but I want to see 2. No, I don't. You can, it's very easy. You can pick it right here. But for now, because I'm only running a single year, I don't really care about annual. So I'm just going to change that to major. I only want to see the monthly values. But you can definitely change this to however you want. So I'm just going to change that title to monthly. And then by default, what GoldSim does is says, oh, you're doing reporting periods? Well, I'm only going to save those values on those reporting periods. That's what it's doing by default, because it's just trying to save memory so it doesn't have to save so much. But you can switch that back to say, no, I want to see reporting and basic steps of 1 day. This means how many basic steps? Well, just 1. Because you could say every 10 days if you want. It's just a way, if you have a lot of results, that this is a way to kind of ease down the total amount of memory that's required just to be saved to run this thing. Okay, so now what you can do is go to your time series properties and change the time display settings to reporting periods, and that allows you to do things like tell me the cumulative rainfall. So for example, right now we're looking at the value at the end of the simulation. Well, no, I want to, or sorry, end of the reporting step. I don't want that. I want the cumulative amount for each of the reporting periods. So for each month, I want to know the total millimeters. The next one that I want to add is the same output, except I want to see all the values on all the days. So that's all plot points. And then that's going to be so many lines that I'm just going to make that a thin line. Hopefully that looks okay. All right, so now we run, now we run this model and let's see what we get. Okay, so we get something like this that can also be changed to look, like those monthly values that we had. But anyway, so you have the option to make that switch. But then you can compare on a single realization what those monthly values, monthly totals are compared to the monthly, or sorry, to the daily rate. That's a nice way to view the data. So I didn't really have to add. You see, I only have a time series here, and I'm already able to show a lot of results with just these simple runs. Okay, another one that I want to show you is what happens if you want to add temperature to this model. Okay, so we can do that. We just copy paste the time series, and then we can put in here. Let's just say mean daily temperature, and I'm going to put a TS because it's a time series. And in this case, we'll use values of, well, I'm really sorry to say it, but I only have it in Fahrenheit right now. But that's okay. We can convert this in GoldSim, so it's not a big deal. But the values are in Fahrenheit, and I've got millimeters over here, so it doesn't make a lot of sense. But anyway, this table already has the correct dates in it. It attempted to do a conversion. Don't worry about those numbers. I'm going to come back over here in Excel and just grab the temperature values and then paste those in here. Okay, so temperatures are there, and now we have the same thing except it's temperature, but we have a problem because we are time shifting randomly. And if you go back to our time shifting settings, you see that it says it's a random annual starting point. Well, if they're both random, then how are we going to see how the two correlate through time? We can't. But we can, but we can't like this. We have to do one more thing here. What we want to do, instead of just randomly for each of these time series, they're not independent, right? We would expect the temperature to drop on a rainy day, for example. So we want these to be aligned, and the way to do it is to change our setting for time shifting to this. Shift data years to align with the date here. And we can have this a dynamic value that changes over time. So for example, we could say, well, I want to define the year myself at the global level of my model. I want to have a thing here that's called shift year. Well, no, we'll call it random year. Random year. And what it is just simply a random number on a uniform distribution that starts at 1948 and it ends on 2017. And the reason I say 2017 is because this time series that we have ends on January 1, 2018. So it doesn't have a 2018. So I'm going to stop there. I hit apply, and you see that's the random part, but we need to, so each realization, we pick this random year, which then can be applied in both of these time series. But just keep in mind that when we do that, so now I'm going to specify my random year. We need to make sure that we round this number. It needs to be an integer, or it just needs to be a whole number. Okay, so we would just copy this equation, or you could write probably a safer way to do this would write an equation outside and put this in there, but I'm being a little bit lazy and just putting the equation right in here. Okay, now they're aligned. Now they pick the same random year. So this would be my preference. And then put this at the global level and add this to all your time series. So now if we were to, for example, Oh, well, I can't. Let's see. I need to add. I need to add my. Let me just create a new chart. So that's precip. Let me just add one that's going to compare precip and temperature. Precip and temperature. So that's going to look at both of these outputs together because I want to see how they correlate. So we'll do precip in red and, well, no, that's not a good idea. Let's do temperature in red and then precip in green. There we go. And just the average is fine. Okay, so now this is where I was telling you we can just switch the units. Right now you see it's Fahrenheit, but we could switch this to Celsius right here. Okay, so now we've run this model and we open up the chart. This gives us just one of the outputs by default, but that's because it's showing probabilities. So if we show just a single realization, then we can see that we have, this is one possibility from the record based on the random year that it picked. And by the way, because we're setting up our own random year generator, now we can easily find out what year this is. And the way that you do that is you simply right-click on the random year and go to distribution result, and then look at the table values, and these are the years that it picked. And you should probably hold down the Alt key and hit the right arrow so that you can get rid of all the decimals in this particular view. That's just how you globally change the decimals, by the way. Hold down the Alt key and move the arrows, the right and left arrows. Anyway, so realization 1 is picking randomly 1995. So then that's an easy way to say, oh, what year am I looking at? Well, you're looking at that year. And by the way, you could also have that year displayed, for example, on your dashboard or something, so that when you pick a specific, oh well, no, that would be the final one. I wonder if you could have that displayed anywhere. Well, I'd have to think about that, because you can be flipping through the realizations, but this might not be the realization that you are looking at over here. See, this is running 70. Anyway, the point is we can find out what year we're looking at. And also the other thing I wanted to make note of is the effect of the rainy days on the temperature. So you do see that there are some drops that are associated with the rainy periods, but there are also drops without rainy periods. But at least we see that there are drops associated with whenever we have rain, we do see drops. So it does seem to be correlated. This is important to be able to align your time series like this. Okay, so with that being said, now I want to show you something a little bit different. Now what I want to talk about is how we can calculate some statistics of precipitation. And in this case, well, it just depends on what you want. So for example, did you want to see the annual peak? So the peak daily rain amount in the whole entire year for each realization. So that would be a very easy one. We could do that with an extrema. And so then what we do is we just put in the units we want to see it in and the input. So in our case, it's the precip there. And then oh, by the way, it's also, you need to set it to be maxima. So that would give you the peak during the year. And then just simply run the model. And then you can right click on the element and go to distribution. And here's your distribution. Now you can make this a permanent chart, so it's always here. You can make it embedded in a dashboard, or you can just grab the specific values you want to see. Maybe I want to see the mean and standard deviation of those peak values. Let's say you could get those and you could display them on a dashboard. But somebody asked in the morning webinar, well, what if I want to use those values? What if I want to use the mean annual precip going forward in my model? Or what if I wanted the standard deviation or something like that? Well, you can do it, but you have to use a submodel. We would have to put this whole thing in a submodel and then we could extract from that the distribution that this develops that we got from this value. So I just want to show you this because there are a lot of things like this you can do with a submodel. You can do a lot of calculations on your precip data. And that's exactly what the tool that I'm going to show you called WGEN does. That's what it does, is it does a bunch of calculations on this time series, and it develops the values you need to input to the weather generator. But anyway, so if we wanted to do this just really quickly, let me show you with a submodel. So you create a submodel, and the time has to be, it's going to be similar to what we were using before. Oh, whoops, calendar. So 1, and then I'm just going 2021 to 2022 is what I think I said. Yeah. The nice thing about running it just for a single year when you're doing Monte Carlo is that it makes it really, really easy to get annual statistics, annual and monthly actually. Annual and monthly statistics are very, very straightforward when you just run it for a single year, because that is the output you get. You can easily just sum them. You can get the extrema value like we're doing, and then just output it. You don't need to add any other logic. But if you're running a simulation for multiple years, 10 years, let's say, and you want the annual, whatever, average, then you'll have to, we have example models you can use to get those values and have them as numbers. You can definitely do it. But this is very simple. So let me just set that up for 1 year, and then Monte Carlo will again be 70. Now you could calculate that number very easily and then just input it. Let me show you how you do that. So we already know the start year and end year of the historic period. So all you have to do is just say that. It's 2018 minus 1948. And so there's the number 70. And so then we could just say realizations to run, reals to run, something like that. Then you can control your submodel to run for that many. So this just, it just is a kind of a way to automate a lot of the steps you'd have to do otherwise if you changed your time series that you're looking at. Okay, so the interface, then we will add this type of interface input, which is a run property for the model. So we'll click on that, and then one of the run property options is the number of realizations you want to run. So then instead of specifying it, hard coding the value, we will just reference reals to run and be done. Okay, so now it will run those. Now we can just take all of this logic up here and cut to the clipboard. So it's gone. Now we can run the main model as a static deterministic. It doesn't need to do anything but just go. That's all it needs to do. Now the submodel is doing all the work. So we go in the submodel and we paste what we had before, and now we would just want this output, and we should probably call this annual peak or annual max daily rain or something like that. We could give it a better description. But that number then, if I go up, that can be interfaced on this submodel. Go to interface, go to outputs, and then this is where it gets pretty interesting. So what you can do here is, instead of just exporting a statistic like I want to know the mean, I mean, that's easy. You could do that and it's nice. You could also say, tell me what the percentile is of some value. But even better is you could export the entire distribution. So you have a probability distribution you're exporting of all the peak values for all those 70 years. And now what you can do is any equation, or well, not any, you can pick from some equations here, and let's say millimeters per day. I'm still working with the same units. One of those functions is built in. It's under special, and it's right here. Whoops, special, and it's under here. Here's standard deviation. I wanted to know what the standard deviation is of those peak values. So now I just go submodel dot, and I can find all the outputs on my submodel. Annual max, there it is, annual max rain, and then we can run the model, and then just hover over it, and boom, there's our standard deviation. Very nice if you need this value going forward in the main model. So what we could do is we could actually, maybe our equations require that we know the standard deviation up front. And so we could then, well, if you only need to run it one time, just put it in a different model and then just use its output. But if you're continually updating this time series, then you might want it in a model like this. And then you would just, if you were running this main model over time, then you might just tell the submodel only update when triggered. And then you could trigger it to only run at time 0. So then it would update its value and then go on with the rest of your simulation. So submodels are really powerful, but they can get a bit tricky and complex. Okay, so the next thing I want to show you is I'm going to skip over. You could do a stochastic output, but we've already kind of talked about that. But what that means is you could apply, say, for example, monthly average values, and then apply a stochastic daily factor to it to give it daily variation. But what I would rather just jump to is one that's a lot more practical, and that is the Markov Chain model. And so we have in our let's see, hold on one second. I need to open this in a different version of GoldSim because I've got it in our newer version. So what you're going to see is the interface, GoldSim interface for our next version. So some of it will look kind of new. You can see that the border is dark. Well, that's because I chose a dark theme. It has different themes you can use. So there will be a few things you'll see that are different. One of the things I really like, though, I just have to mention it because it's really nice, and that is the color palette is new, and it's also very easy to save your custom colors, and also pass them to your coworkers that maybe need the same colors. So that's very nice. But anyway, what this model does, it's called a Markov chain, and Markov chain, it needs two things to be a Markov chain. It needs to be able to change state through time. It needs to remember what state it was previously, but the state might change through time. It might change randomly, or well, not exactly randomly. It might be controlled a little bit, but you might not necessarily know when it's going to change, but it might be flipping back and forth. And the other component that you need is you need at least two different states. Okay, it's two or more. It could be more than two states. In a rain simulator, all we really care about is the two states of dry or wet. But if you were at my webinar last time, you would have heard I talked about Markov chain modeling in a business type application, and so we were modeling three different states: a bear, a bull, and a stagnant market. So three different states we were switching between. But anyway, in this case, we're switching between two, and the status element is perfect for any kind of situation in your model where you want to switch between two different states, and you want it to hold that state until it's told to do something different. Lots better than an if statement. Lots better than in fact, a lot of times a selector element, an if statement, it cannot do what a status does. And a status is perfect for this, where it can hold on to a state it's been given and keep it until you tell it to change. So it does know what it used to be on the last time step. That's important for Markov chain. The other part is that you have something, some mechanism that will change the state in your model, but importantly, be a function of this previous state, and that's what makes it gives it the chain part of its name. Okay, so in this model, this is the Markov. I'm going to expand the window here because we don't need that Excel anymore. Okay, so this model, what it does is it takes first of all probabilities that today will be wet. What's the probability that today will be wet? And it's divided them up into two different categories, depending on whether or not yesterday was dry or wet. And so what this does is it has these two different sets of data. The first one, PWW, meaning, and these acronyms, or I guess their initials, whatever, they came from the original Fortran code that's referenced up here. So that's why some of these are used this way. But anyway, PWW is what's the probability that today's wet if yesterday is wet. And then PWD, and let's just look at the values, by the way. So you can see some of them are pretty high values, 50%. Then if you go to PWD, and you look at those values, you can see they're much lower. And that's because it's a smaller chance that today will be wet if yesterday was dry. And so that's how you get it to give that kind of, especially for arid regions where it might go for days and days without raining, then you can do that, you can model that with these probabilities. Okay, so now the next question is, well, how on earth do I come up with these? How do I come up with these numbers? And you can do it very easily with a help of one of our models. So let me show you another website. So if you go to our help center and then just type in WGEN, this is the weather generator model that we have. I highly recommend looking at it if you want to do any kind of stochastic weather simulation of temperature, radiation, or precip. Then I would recommend this. So what you do with this is you can first generate the parameters that it needs to run. And that, all you need are time series. So if you look at this model, what it does is it essentially just tells you, or just asks for the time series records. And you can put in, you don't have to put all of them in, but that's, you need to put precip, min, max temperature, and radiation time series in here if you want to simulate all 4 of those things. But if you don't, if you only want precip, then just put the precip in and ignore the other outputs. But when you put those in, you need to specify the duration of the run and so forth, and then also specify the type of unit and run it, and then it will output these values, also export them to Excel, making it very easy to then copy and paste into the WGEN model, which I guess I might as well just mention it since I'm here. The WGEN model is here, and you can see that the inputs that it requires look very similar to what we just saw before. This is the output from that previous model, the parameter generator. Let's see, are there any questions at this point? No, okay. So you just simply paste them in. You just copy them from Excel, the Excel file it generated, and paste them in here, run it, and now you will have the probabilistic climate output values that you need for your model to do, for example, runoff runoff from a catchment, for example. Okay, so what I want to do then is, oh, this is not the model I wanted to look at. No, we don't need to save that. This one. Okay, so this is just a simplification of part of that WGEN model. It's actually much simpler. All it has is a state changer. State changes between wet and dry, followed by the magnitude of rainfall that is applied. And so to get that number, you need the monthly means and standard deviations. And that can also be obtained using that tool I just showed you. So those are the only factors you would need. But like I said, the WGEN model itself, it has a few more, a little bit more going on in here. So this is a bit simpler, but it still works well. In fact, you could look at calibrating this to a site by comparing statistics. So for example, monthly means, compare monthly max, min. I mean, there are a lot of things. Duration of storm, for example, you could extract what the average duration of storms is and compare that. So there are lots of ways of validating this model. Or sorry, I guess we should call it calibrating. But anyway, we are using a gamma distribution with a mean and standard deviation to then just apply a factor to, it says rain magnitude divided by days in month. Okay, so rain magnitude is actually in millimeters. And so all you do is just run the model. And then if we look at the history, you'll see something somewhat similar to what we saw before. But if you look at a single realization, then you'll see that it does look, I mean, at least for the areas we were looking at before, similar in how the rain events are more sparse in the summer and closer together in the winter and spring. Okay, and so that's being taken care of by putting in are these values. So I guess the question is, well, why would we use this approach to model rainfall if we have a time series already? And the answer to that is that this simulation is based on historic record, because we developed these inputs by running it through a program, or running our time series record through the program to get those. It is based on it, and you can even compare. If you go to the WGEN model, you'll see there's a verification container in there. You can see how it stacks up against measured values if you want to see it. So that's important to note, but also that these synthetic generators, or these stochastic generators, what they do in addition that you're looking at historic time records don't do, is that they will result in scenarios that you've not seen in the past, which could be important. And it allows you to run a lot more possibilities through time. So it could be really helpful. But that's where I wanted to end up, was to show you the WGEN model, which I already did show you. But that is also using, let me just go back to it. Let's see. Let me open it again. Okay, so here's the WGEN model. Looks like this. And so you can see there's a lot more going on, but that's because we're looking at temperature and min-max temperature and radiation. So there's all that going on. And then it's just, if you look at the rain generator, you see it's a bit more involved. And I mean, not a lot, but there's some correction that you could do, and there's also a different way that it deals with the magnitude. But anyway, it's all documented, so you can look it up. But that's the component that we were just looking at, the Markov chain, to generate that preset. But the cool thing about this model, about WGEN, is that the temperature and the radiation are both affected by whether it's a wet day or not. And so that's important, to have that correlation in there when you're doing randomly generated or synthetically generated rain or weather patterns that drive your models. But it does make it so that it's more realistic. Also, so here's the verification container I was talking to you about in here, where you can look at, I've split them up into rain, radiation, and temperature. So for example, in temperature, you can look at things like what's the 95th percentile comparison, or what's your min monthly temperature comparison, those kinds of things. Rainfall, we compare things like how many days greater than 2 inches did you have? These are all verification tests that come out of the Fortran code that you can get if you want. And I think I might put a copy of that. I do. So I've just copied and pasted the Fortran code that we used to essentially just rewrite the model here. But in the verification, we also, not only do we compare it to measured outputs, but we also compare it to the Fortran outputs. So that's WGEN, and it's a really good way to generate your precip data, and based on historic records still. And next week we will talk about modeling temperature, radiation, and so that we can calculate evaporation, for example. So that's it for this presentation. I'm going to stick around for a bit to see if you have any questions. Happy to take any questions that you might have. But if not, if you're leaving, thank you for joining, and we will see you next week, hopefully. Okay, so back to the question. Oh, but the person left. Well, sorry to see it. I guess they can watch the video recording, but they wanted to see me talk again about interpolation. But we do actually have I think we have a webinar on that, so you could just look up interpolation in our help center and find that one. Or you could just watch this recording again. I needed to start recording again. Sorry about that. Let me repeat the question. Does the latitude entry in WGEN parameter mean the model is only relevant for the US? No, not in this case. No, it does not mean that. It should work. It should work fine, actually. Now, there is another model that we have on our website. Let me go back to it. If you go in our help center and go to forecast, type in forecast. This model. Hold on. This one, weather forecast from web services. This one it won't work in a different country. This one it uses the U.S. National Weather Service web data interface, their API, so that I could program write a little program that's compiled in a DLL. It's separate from GoldSim, but GoldSim talks to it. And so what it does is when you run the GoldSim model, it goes online and it gets the forecast for this lat and long. But those values, and I tried to put a check in the code that will tell you, hey, you're outside the range. And you can also limit those values in the dashboard too. But anyway, the point is, if you tried to enter something in a different continent, this wouldn't work, this model. But I think WGEN, because all it needs is the location, all it needs is the latitude. Whoops, I went to the wrong model. All it needs is latitude, not longitude. And all that's doing, I'm pretty sure all that does is provide the base signal for the temperature fluctuation through the year. That's all that we use that latitude number for. It's like a sine wave. If you think of it like a sine wave that just oscillates with a wavelength of a year, that's how it's calculating those temperatures over time, which look like this. So just think of it as it's not a sine wave, but it's similar to that. And that's what the latitude number is being used for. So I hope that helps. So somebody else asked, oh wait, there are more questions coming in. Sorry, I shouldn't have talked so long. Let me expand this. For your precip record going back to 1948, can you show how the uncertainty changes depending upon the period of record? Say you remove data every decade, how would that affect your predictions? Oh, I see. So you're talking about trends. You're looking for a trend, maybe. Um, what we set up doesn't immediately have that, but it's a really good point, actually. If that's what you're talking about, are you talking about, for example, we might see over the annual runs or over the whole entire period, we might see annually a slight shift in one direction or another in any of the monthly or annual values? Is that what you mean? Okay, yeah, that's what you mean. Okay, yeah, so yeah, we could certainly do something like this. It would be, you'd think of it as like a pre-processor that we'd build. So we'd build one model, but it would have inside of it possibly um, a way to extract out these systematic factors that are being applied over multiple years. Yeah, that would be interesting. In fact, we could even adjust it so that the historic record, well, no, I'm getting ahead of myself, I'm sorry. But the point is, yes, we could run let's say a preprocessor. So it'd be a submodel in the model. What it does is it goes over the entire historic record and it extracts out the annuals. And from that, we can then calculate, say, for example, a change over the last whatever many years. So yeah, I think we could do that. Yeah, it would require a submodel though. But it's an interesting idea, almost interesting enough to have an example. But unfortunately, I don't think I have any examples that show that. But a good idea. Okay, next question. If I want to predict a temperature increase of 2 degrees Celsius, In the Monte Carlo model approach, do I have to modify my time series directly? Oh, no, 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 you don't need to. Yeah, that's the beauty of having it in this simulator. In fact, if I just go back to the simple one, maybe, I don't know if that would be, well, let's just say the simple one, okay? Because it's got less things moving around. But let's say we just wanted our means to be changing over the years. So there are lots of ways we could do it. We could put these in in a lookup table where they change over the years. So for example, just imagine we have 10 columns of these, and we have different values. They might be changing over the next 10 years, and then we would just refer to the year in here. And so you could run long simulations, 10-year simulations that show the chance of it going up. But what I would say is maybe instead of that, maybe we look at adding maybe a separate function that's just applied to these values. Maybe it'd just be a scalar, so maybe an annual adjustment to the probabilities of it being wet. Maybe it's more likely that maybe the probability wet on wet is going up, and maybe the probability wet on dry is going down. I don't know what these situations are that you might have, but whatever they are, then yeah, you could easily just apply that. But I think it probably requires you run a long-term simulation, I would guess. So you'd probably be looking at, I don't know, 2028 maybe. So you'd be looking at a 10-year forecast. I could see that being, or maybe longer than 10 years. But the point is, with year-on-year bias or year-on-year adjustments like this, yeah, you would need a long duration, which this tool could still work easily for that. It would just, now you need to apply whatever these annual factors are. Okay, let me move on. I hope I answered that okay. Can you complete a Monte Carlo run referencing different synthetic rainfall data sets saved in different tabs in different Excel files? Yeah, sure. I mean, you could, but that's, no, I'm sorry, I'm just thinking about how you would do it. I think what you'd do is you'd have all the different possibilities in different columns. And so it looks like you said 100 different ones. Okay, so let's say you have 100 columns of time series. Okay, so we're just imagine dates down one side, realizations across the top, or in your case, whatever you call them, scenarios or something. Different data sets. Okay, so you have 100 different data sets, 100 columns. So in GoldSim, yeah, you could certainly refer to a random column, or start with column 1, and on each successive realization, you just increment up 2, 3, 4, etc. Very easy to do. People do it all the time. So the answer to that question is definitely yes. You can easily do that. So I hope that helps. Let me know if I'm not answering it completely, and I'll try it again, because I feel like I'm maybe starting to get off into different subjects a little bit as I try to answer the question. Since there aren't any more questions, I will close this up and just let you know that, again, this will be recorded, or this is recorded, and it will be posted in our archives. And I do hope that you can make it next week, where we will talk about, we'll essentially continue where we left off here, starting into temperature radiation, solar radiation, and evaporation. All right, so thank you for joining, and I look forward to seeing you next week.